Alright, so today after school we were looking at discontinuity, just like we did in class today. So the directions for this problem is find all points of discontinuity and name their type. So you've got four different types of discontinuity. You have the oscillating, which we will never see. You have infinite, you have removable, and you have jump discontinuities. Jump discontinuities only happen with piecewise defined functions and weird ones like absolute value. We don't have that here, so we're only really looking for infinite discontinuities as well as removable discontinuities. So to do that, that's step number one, which is set the denominator equal to 0. So I'm going to take x squared plus 7x plus 12, set that equal to 0. And to solve that, you can just factor this. It's really quick and easy. X plus 4 times x plus 3. And then you're going to use the zero product property. I'm going to skip over that step just as far as time is concerned, but you'd use the zero product property and set x plus 4 equal to 0 and solve that. That would give you x equals negative 4. Then you would take x plus 3, set it equal to 0, and that would tell you that x is equal to negative 3. So those are your 2 points of discontinuity. Those are guaranteed to be points of discontinuity. You just have to determine the type. So to determine the type, you have to figure out whether you have a vertical asymptote, which would be an infinite discontinuity, or a hole in the graph, which would be a removable discontinuity. So to do that, you're looking at the limit. You need to look at the limit as x approaches negative 4 of this graph, and then the limit as x approaches negative 3 of this graph. But we know a shortcut. As long as we understand that we are taking a limit, what we can do is just plug negative 4 into the numerator. So moving on to the next slide, my numerator is x plus 4, and my two discontinuities are x equals negative 4 and x equals negative 3. So if I plug negative 4 into the numerator, negative 4 plus 4 equals 0. What that's telling me is if I were to do the limit, I would have 0 in the numerator, and I already know I would have 0 in the denominator. That's 0 over 0. And what we know is that that limit is going to exist. It's not going to be infinite, and so because of that, x equals negative 4 is removable. And I'm spelling as best I can with my finger on my iPad. There you go. X equals negative 4 is a removable discontinuity. Cool? Cool. I'm going to erase that. No, I won't erase that work. We'll just keep on going off to the side here. And so we have x equals negative 3. So again, I'm going to take negative 3 and plug that into the numerator. And so I'll do that off to the side here. Negative 3 plus 4 equals 1. Again, you are actually doing the limit. This is the numerator. The numerator is going to be 1. The denominator is 0 because that's where the negative 3 came from. 1 divided by 0, we can't do that, but we're looking at the limit. So as the denominator gets closer and closer to 0, the numerator gets closer and closer to 1, and 1 divided by something that's really, really, really close to 0 ends up being infinity. And so this limit is infinity. That's the definition of a vertical asymptote. So I know that at x equals negative 3, we have an infinite discontinuity. And there you go. That's how you determine whether a function has infinite discontinuity, removable discontinuity, or jump discontinuity. We will see jump in the next video, and we didn't have any oscillating because we never are going to.